Hello, my name is Jiewei. I'm a PhD student in chemical engineering of UC Davis.
Hello everyone, my name is Jiewei Chen. I'm a PhD student of material science at UC Davis. This video is on our course project of STA 141B, Data and Web Technology of Data Analysis.
Our project was performed in Python, and if you're interested, please continue to watch. This project is on the current job market analysis. The motivation of this project is that I am a PhD student in chemical engineering and Jiewei actually majors in material science. As this is a course project in a data analysis class, we would like to explore and compare the job market of these three majors: chemical engineering, material science, and statistics. The questions we would like to answer with this project include: what are the common and specific skill set for each major? What are the salary levels for different majors? Should we pursue a degree in statistics if we wish to earn more? And as graduate students, do we have any advantage in finding a job compared to undergrad students? Also, what are the job market demand for different majors? And some of these questions are analyzed for full-time job and internships separately. To answer these questions, we borrowed data from the Indeed website. It's a job searching website where you can specify the keywords like job title, major, location, job type, and so on, and it will return a list of job posts that match your keywords. For example, this is one result of the search of statistics. We can obtain the information of the job title, the company name, and the location of the company, also the URL that links to a more detailed job description. And other information such as the date of the post, the job key, and more can also be extracted from the API of this Indeed website.
Okay, let's talk about the methodologies we used in this project. Basically, we applied every technique we learned from this course. For data extraction, we request the API from Indeed website, and the web scraping was built for soup of each web post. And for job market demand, we used the geographical data analysis and data visualization techniques. To obtain skill sets, degree requirement, and salary, we used the natural language processing and regular expressions. To compare these results across different majors, we used the various data visualization methods. Here is a snippet of the data we requested from Indeed website. We saved our data into CSV files. Each row corresponds to one job post. From this data frame, we can get where a job is located, what is the company name, the date the job was posted, the job title, and the location of the job. The most important is the unique URL link for the job description of one job. This is an example of the job post following the URL. From this website, we can extract the job qualification, salary level, and degree requirement. We restrict our search in California to have a more controllable size of data, but the methods can be easily extended to a broader area and even other majors. And this table shows how many posts we scraped for different majors.
Let's first get a general idea of the current job market in California. Let's see where are the hiring companies and if there is any difference in the job locations across different majors. Here's a little map that gives us a glance of the distribution of the hiring companies. Each dot on the map represents a company, and the colors of the dots distinguish the three majors. Not surprisingly, there are two clusters on the map. One is at the Silicon Valley, and the other is around Los Angeles. Another interesting observation is that the STAT companies are more closely centered at these two locations, whereas the chemical engineering and material science companies are more widely distributed. We also created 3 interactive maps if you would like to have a closer look at the job posts. The companies are pinned on the map, and the job title and the company name will be displayed if you click on the pins.
Now let's see if graduates have any advantages in the job market. To answer this question, we plotted the number of jobs of different degrees. The red bars correspond to full-time jobs, and the blue ones are internships. and the darker part in each bar shows the number of jobs only requiring bachelor's degree. Similar patterns can be seen across 3 different majors. It can be easily found that the majority of the jobs only require a bachelor's degree. For internships, the percentage of graduate is slightly higher. It is interesting to find that there is a high demand for graduates for internships of material science. One wild guess could be that these companies know that graduate students from material science couldn't find a job, and they tend to hire them with low salary for internships. Also, we compared the population of undergrad and graduates and their demands. The population data of the statistics major and engineering majors come from the National Center of Education Statistics. They are data of the entire U.S. in 2014 to 2015 academic year. And the job demand data were obtained from Indeed website and only in California. Since the data are not on the same page in terms of time and locations, we only compare the percentage of different degrees. Assuming the California data is representative for the entire nation, we made these 2 sets of pie charts to see the percentage of population and their demands. As we can see, the percentage of undergrads is larger in population than that in the job market. This indicates that it might be easier for undergrads to find a job. However, another possible reason is that people with higher education levels may prefer to continue their career in academia rather than industry. Another question we would like to answer is, what is the common skills shared by different majors and what are the unique skill sets of each major? Here are our findings. First, we plotted the word cloud generated from the job description of different majors to get a glimpse of the difference of these 3 majors. We can see a significant difference among different majors. However, simply from this word clouds, it is hard to see the common and unique skill sets required. So, we then made a further comparison to see how many words were shared by these 3 majors and how many unique words they have. Here is the result presented in a Venn diagram. There are 31 important words shared by these majors. These words are more likely to be a general requirement of jobs. Actually, they can be classified into 2 categories. One is the words related to personal characteristics like independent, collaboration, coordination, and etc. Another category is the fundamental technique requirements, such as Excel, R, and software. We also did the pairwise comparison between each 2 majors. There are about the same amount of words shared by statistics and the other 2 majors. And there is a large overlap between chemical engineering and material science. It is not surprising to find these 2 majors are closely related. Actually, they were a single department last year in our university. Since we too are very familiar with our own majors, in our next step, we only dug into the unique skills set for statistics major. After some research, we generated our own keywords for statistics major to see which skill is the most important and basic skills we need to learn. This is a bar plot showing the portion of jobs requiring each technique. It can be found that Excel, SQL, Python, and R are the top 4 skills which are largely required by companies. In later sections, we also compare skill sets of different salary levels.
Finally, let's talk about money. The distribution of the salary levels are very interesting. First of all, the distribution of the stat and chemistry majors are very similar. The average annual salary is around $70,000. Chemical engineers actually earn a little bit more than statisticians in general. For material science, it seems that the entry salary level is much higher than the other majors. However, on the other hand, the highest salary level is very limited as well. the distribution is pretty narrow, and it seems that there's not much space to push up your salary for a material scientist. It's probably a good idea for Jiewei to pursue a degree in statistics. Also, especially for stat and chemie majors, the higher the salary level is, the fewer people there are. So our next question is, how can you earn more? Is there any particular skill that can boost your salary level? Unfortunately, there's no quick answer to this question. We equally differentiated the job posts according to the annual salary they offer. The high salary level jobs are indicated by the red bars, and the jobs in the lowest job salary level group are represented by the lightest color. The most popular skill set, including R, Python, and Hadoop, basically the contents of the 141ABC course series, are all commonly required regardless of the salary level. Some other skills are required by some companies, but not the others. We do believe there should be some correlation between the skill set and the salary level, but we did not find any particular skill that is special for the high salary level group. One possible reason is that the data is quite limited. Not all the job posts would specify the salary level, and only about 10% of the job posts we scraped provided the salary information. The sample size is relatively small to begin with. Another hypothesis is that it may be the size of your skill set instead of a specific skill that determines your salary level. This is the end of this video.
Thanks for watching! If you are interested, please check out our information box below for a link to the webpage of this project.